Hello, my name is Andrés Bolano, and today I will explain how inferential statistics and sampling methods are essential for analyzing urban mobility problems in cities like Bogota, as well as for evaluating public transportation systems and designing better policies. First, let me answer the questions. How can sampling method improve the analysis of the urban mobility problems in cities like Bogota? Sampling methods are crucial because they allow researchers and city planners to collect representative data about mobility patterns without the need to study the entire population. Which is often impractical due to logistic and economic constraints. Well-designed sample can capture the diversity of transportation users, modes, and times, reflecting real travel behavior. For example, by applying strategic or random sampling techniques, analysts can ensure their studies include all relevant zones and time periods such as peak and off-peak hours. This leads to more accurate results about average travel speeds, congestion levels, and user satisfaction, which ultimately support evidence-based decisions to improve urban transport systems. Now for the second question, what are the advantages for using confidence intervals when evaluating public transportation systems? The confidence intervals provide a range of values within which the true population parameters such as the average speed of buses or the proportion of trips during rush hours is expected to lie with a certain level of confidence. This quantifies the uncertainty associated with the estimates and helps decision makers understand if changes in the systems, like new routes or adjusted schedules, generate statistic significant improvements. For instance, when evaluating the average waiting time at bus stops in Bogota, confidence intervals inform whether observing improvements are due to real changes or just random chance, leading to more reliable and transparent evaluations. And third, describe a real-world scenario where statistical inference could lead to better environmental or mobility policies. A practical example is the estimation of CO2 emissions from public transport. Suppose the city wants to measure the impact of a new electric bus fleet by collecting sampling data on energy use and emissions before and after implementation and applying inferential statistical methods. Analysts can determine if the new fleet significantly reduce emissions. Policymakers can then use these statistically supporting findings to justify investments in cleaner technology, design emission reduction strategies, or revise traffic regulations. In summary, inferential statistics is fundamental in the academic formation and future professional development because it enables me to interpret data correctly, make decisions based on evidence, and contribute to creating more efficient, sustainable, and fair mobility policies in urban environments. Thank you for watching.